Hi, this is Brendan with Cusack Prep, and this is going to be another video dealing with the double angle formula. In this case, we're going to be going over a couple of pretty straightforward examples regarding tan of 2x. So for tan of 2x, in both of these problems, we can see it is the only trig function that appears. We only have tan of 2x. We don't have anything else. When that's the case, all we have to do is isolate tan of 2x. So for this first problem, I'm going to add 1 to both sides, and that's going to lead me to tan of 2x is equal to 1. Now, to figure out what x is, I need to do inverse tangent. So I say 2x is equal to the inverse tangent of 1. Now, if you know your unit circle values pretty well, you know that tangent is positive in the first quadrant and the third quadrant, and it equals 1 at the pi over 4 reference angle. So moving up here, we can see that 2x would have to equal pi over 4, that's the first quadrant value, as well as 5 pi over 4, that would be our third quadrant value. Now, because it's 2x, we again have to go around the unit circle twice. So we don't just stop at pi over 4 and 5 pi over 4, but we're actually going to have to add, so let's say pi over 4 is right here, I have to go all the way back around the unit circle. So I'm basically going to be adding 2 pi to pi over 4. So if I have pi over 4 plus 2 pi, that's going to be pi over 4 plus 8 pi over 4, which is going to lead me to 9 pi over 4. In the same way, I can go ahead and add 2 pi to 5 pi over 4. And when I do that, I'm again adding 8 pi over 4 after finding the least common denominator. And I'm going to end up with 13 pi over 4. But we're not quite done, because in all of these cases, it's 2x equals all these things. We're not trying to solve for 2x. We are definitely looking for x. So we're going to divide everything by 2. When we divide a fraction by 2, it's the same as multiplying by 1/2. So we're going to end up with pi over 8, 5 pi over 8, 9 pi over 8, and finally 13 pi over 8. And these 4 solutions all are within the 0 to 2 pi interval that you're typically looking for. We've got another problem down here, so we'll just run through this one really quick. And for this one, kind of same starting process. We're going to go ahead and subtract 1 from both sides and divide by root 3. So we're going to end up with tan of 2x is equal to negative 1 over the square root of 3. In order to solve for 2x, we're first going to rationalize this. So multiply by root 3 over root 3. And we'll have tan of 2x is equal to negative root 3 over 3. Now once again, this is somewhere where you're going to need to know your unit circle values. And that 2x is going to equal the inverse tan of negative root 3 over 3. These values correspond to pi over 6, and tangent is negative in the second quadrant as well as the fourth quadrant. So we end up with 2x is equal to 5 pi over 6. That's going to be our second quadrant value. And for the fourth quadrant, it's going to be 11 pi over 6. But once again, for these double angles, we have to add and go all the way around the unit circle again. So if I add 2 pi to 5 pi over 6, that's like adding 12 pi over 6 to 5 pi over 6. I'm going to end up with 17 pi over 6. If I add 2 pi to 11 pi over 6, same thing, that's like adding 12 pi over 6 to 11 pi over 6. So I'll end up with 23 pi over 6. Finally, we can't forget to divide both sides by 2, and when we do that, we end up with 5 pi over 12, 11 pi over 12, 17 pi over 12, and finally 23 pi over 12. And that'd be your answer. That's how we do these types of problems involving tangent of 2x. There are slightly different variations of it. We'll try to get into that. That'll probably be in the next video. Thanks for watching.